to have a trivia game using the LCD screen and the keyboard using to select the answers. So our project is interfacing the keyboard with the Nexys board.
Basically, the task we set for ourselves as far as requirements for when it starts out, it has to have a welcome display, which in this case I'll say it's like welcome to trivia. Then also, so you push, then you push a button. Doesn't matter what button you push, it brings up the question. And to scroll through, it's just you just push the button, and it will just drop the line so you can read all the question. And it brings up the answers, and it's just A, B, C, or D. And then, yeah. So basically, the block diagram, you got the keyboard connected to the PMOD. It's fairly obvious. The UART was our issue. The UART.
The hardest part with the UART was setting the baud rate correctly, because when you start out, you need to actually find the correct baud rate of the keyboard using the oscilloscope. And then you have to multiply that by 50 million, which is the clock frequency of the board, and that gives you a new clock rate that the UART operates at. The problem is that number that you get is only a rough estimation of the actual baud rate from the keyboard. So, actually that's farther on in the presentation, I'll get to that later. And then with the rest of the software, you have your microblaze processor with the peripheral bus, hooked into the UART, and then we have out to the LCD data. Our design, we modularized it into a few parts. The most important ones, reading the receive FIFO from the UART was kind of hard because you don't actually, it doesn't send in the character that you have typed, it sends in 2 scan codes. It pushes the scan code of the button you pressed, and then the second scan code that it sends in is the scan code relating to the fact that you let go of the button. If you don't let go of the button, the keyboard resends that scan code every 100 milliseconds, and it just keeps filling up the receive FIFO. And then we have our own lookup table where it takes the scan code from the FIFO and then checks to see which character it is before writing it back out to the LCD screen. And then at the end, through the main function, we just have it so that at the end of the quiz, it tells you what you got correct on the quiz or trivia. As I said earlier, understanding the valid baud rate was the hardest part of our testing. It took the most time. And understanding, even though we were never actually transmitting to the keyboard to say turn on the number lock, scroll lock, caps lock LEDs, we still needed to make sure that the FIFO was reading at the right rate, sending at the right rate. And so we had it turn on the LEDs. And then we also needed to figure out, part of the testing was what actually is put into the FIFO when you push a button on the keyboard. Because when we first started off, the baud rate wasn't exactly correct. It was a little bit too low. So you would push it, you would push a button, and it would actually believe that there was valid data in the FIFO. And then you would say a character would show up on the screen and it would be the wrong one because it wasn't reading the data that you were sending at the correct rate. So it would be it would show up as a different character. Usually it was the character that shows up for unknown. It's a weird, I don't know how to describe the symbol. It looks like a Greek character. Can I finish off? Okay. And yeah. So, are there any questions before we demo? All right. We're at bench 10. If anybody wants to head over there. whoops. How do I do this again? Now, initially, we had it programmed to a specific keyboard, but this morning I went and plugged it in the senior project lab, and this is part of whole, the Petrosky argument that we heard about yesterday. You can only learn from catastrophic failure. I forgot to set on the current limit, and it blew out the keyboard. So this morning we had to scramble to we had to find another keyboard that worked and find a new baud rate. And so what I learned specifically is that it's a very, very wise idea to always have a current limit on. Otherwise, you'll be scrambling for time. Hold on.
Alright, so there's our welcome. Any button. Okay, our first question here that we've got is what year was Cal Poly founded? Push a button again, finish off the question. And then it brings up your list of options. So in this case, we've got A is 1913, B 1906, C 1895, and D 1909. So anybody care to take a guess?
1906.
Oh gee, look at that. The right answer. If you were to have gotten the wrong answer, I'll go through this again. Okay, so we'll just say A. It comes up with sorry, try again, and you just hit the reset button and it brings you back. Yeah.
And
that's about it.
yeah. It's our project.
How many questions do you have?
At the moment, we only have one. I started rechanging things when we figured out that the baud rate was wrong, and it turned out I didn't actually need to change anything in the code. I just needed to rechange the baud rate. So at the moment, we just have one question.
Okay, but in principle, it's there.
Yeah.
Okay. Great. Let's give him a hand.